All right, today we are going to review factoring quickly. And it is a review, okay? I realize we may be, some of us may struggle with it more than others. This is not one of the things that you can try and ignore and think it's going to go away, all right? And I'm never going to stress anything greatly that isn't really important. I mean, we'll go over some things and I'm like, here, you kind of need to know this, but if you don't really remember it, it's fine, whatever. If you can't factor, you're not going to be able to progress in your math career, period, end of story, okay? And do it quickly and accurately and without photo math. That's the biggest thing, okay? So as we go through this, like I said, I'm going to go pretty quickly because I want to kind of hit all the different kinds. But if you have any questions, please stop me and ask me, okay? So the first thing that pops up in your formative should be this, okay? It's a factoring flow chart, which we're not going to spend much time on today. If I haven't already, I'm going to put it in as a document in today's folder in Schoology. I can't remember if I did that or not. I was going to, but I'll double check. And if it's not there, I'll do it at lunch. But anyway, this gives you the special cases, some of the rules. It's a good thing to refer back to if you're stuck on factoring. It's just a good little reference sheet for you. But we're going to start here with GCF, which maybe I could have skipped that part, but you know what? We're going to do it anyway. So GCF, greatest common factor, old business. But you always want to make sure you're looking at the greatest common factor and not just the common factor. So the GCF, not just the CF. All right, make sure it's the greatest one. So when you look at number 1, between 24 and 54, what's the biggest number we could factor out? 6. So I can factor out a 6. And how many y's do I get to take out? 3. So 6y cubed. That leaves me with 4y minus 9. Okay? And if you factored out like a 2 or a 4, a 2, and you realize, oh, I could have done more, that's fine. You go back and just make sure it's the greatest common factor. You're good. That's it. Number 2. Now, nobody yell out numbers to me. Here's what I want you to go through this thought process with me. We got a 51 and a 17. Now, I would imagine when 24 comes up, you can think of the factors of 24 pretty easily, I hope. 51 is probably not something that pops into your mind for all of you. Maybe some of you, just depends on how your mind works. But do you know the rule for looking at a number and knowing if it's divisible by 3? Adding the digits? Okay. So I know it's not divisible by 2. And that's okay, 17 isn't either. But maybe it's divisible by 3, so if you add the digits, 5 and 1, and you get 6, whatever number you get, if that's divisible by 3, then the number is divisible by 3, and you're not guessing and checking. Make sense? So we're hoping 3 will go into 51 17 times. Does it? 3 goes into 5 once with 2 left over, so yes. So the biggest number I can factor out here is 17. And then how many A's can I take out? 3. How many B's? 4. And that leaves me with 3a squared plus b. Easy enough? Hopefully. Don't mess up GCF. And when you're factoring, you always want to look for a GCF first because it'll make your life easier if you actually do that. Okay. All right. Once you're done with that, move on to the next section there. And let's look at difference of squares. Difference of squares. There's no sum of squares, only difference of squares. So your perfect squares are numbers like 1, 4, 9, 16, 25, 36, and so on. You should know your perfect squares up to 25. And that doesn't mean just those first 5. That means like this is 1, 2, 3, 4, 5. You should know them up to 25 so you can get through this stuff quickly and accurately again without you getting stuck on numbers. So our rule for factoring a difference of squares. So difference of squares will look like this. A squared minus b squared. This is super easy. This would give me a plus b, dual credit, times a minus b. Okay. Difference of squares comes up a lot. Make sure you can recognize it and handle it so it's not an issue for you. So when I look at number 3 here, I've got this is a perfect square, this is a perfect square, so I know that this is going to give me two binomials. And then I take the square root of 36w squared, that's going to give me 6w. And that square root of 25 is going to give me 5, so I get 6w plus 5 and 6w minus 5. And I'm done. Oh, no, that's a good question. It could be minus then plus. And I don't know that I even do it the same way every time. And if this is your answer in Delta Math, whether you put it plus then minus or you put it minus then plus, it doesn't matter. It's going to take it. It's fine either way. All right, so then let's look at number 4. This is a perfect square. This is a perfect square. So that means, again, I get a binomial. What is the square root of 1 over 144? 1 over 12. So it's going to give me 1 over 12 plus, and then what's the square root of r to the 6th s to the 4th? Anybody know? See if. Yes. Okay, very good. Because if I want the square root of r to the 6th s to the 4th, isn't this the same thing as r to the 6th s to the 4th to the 1/2 power? That look familiar? And so basically then power to a power, you're basically just dividing all those in half. So then this is going to give me r cubed s squared. So then I'll get 1/12 minus r cubed s squared. And that is my difference of squares. Okay, we good? What questions you got? Knocking some cobwebs off, right? You need to be factoring geniuses. We're going to do it a lot. It comes and goes, but it's never going away. And the only way you get better is practice, by legit practice, not photo math practice. Okay, then let's move on to cubes. So your perfect cubes, you could have 1, 8, 27, 64, 125, 216, and so forth. Okay. So your rule for factoring, if it is the sum of cubes, so that means I have a cubed plus b cubed, you're going to end up with a binomial times a trinomial. Right? So you have to take the cube root of each term, so that would make this a. So this will give me a plus b. Then in here, you work off of this. You square the first one, so you get a squared minus, you multiply the two together, a times b, plus, you square this one, and you get b squared. We'll talk about the signs here in just a second, how you know what to do with them. This is a very simple process. It comes up a good bit. I mean, I wouldn't say a lot, but you may not see it for a while, then all of a sudden you got to factor it and you got to remember this rule. It's not that big of a deal. The pattern for the numbers that go in there are no big deal. Here's how you know what to do with the signs. You use the acronym SOAP. That stands for same, opposite, always, positive. So write that down, then I'll explain it. Same, opposite, always positive. That refers to the signs. This is the sum of cubes, right? So your signs here are the same, opposite, always positive. That's how you get the signs in there right. So when you go to factor, you go, all right, I know this is going to give me a binomial and a trinomial. This is the sum of cubes, so this is going to be the same, opposite, always positive. You can get your signs in there before you worry about anything else, because that's most likely what you'd mess up on anyway, if you messed up on something. So then the cube root of h cubed is h. What's the cube root of 125? 5. Okay, so then this is going to give me, dual credit? Yeah. Okay. This is going to give me h squared minus 5h plus 25. Okay? Easy enough? Yeah, you can just put it on my desk. It's fine. What questions do you have? All right. Y'all do number 8 on your own. And those of you that just came in, you can go back and watch the first part of the video to get the rest of that. So once you do number 8, then check yourself with me. And if we are good, we will move on. Any questions on the sum of cubes? Gabriel, you're missing something on your second one. Yeah, on the 4, on this right here. Go back and look at what you wrote for this. Let's see if I can catch anybody else. Yeah. It's all good. Just want to make sure you have the right thing in your notes, because if not, then sometimes you go back and, y'all get confused, like, where the heck did this come from? Or why did she write that? I didn't write that. All right, are we good? Okie dokie. So let's move on then. All right, so let's look at the difference of cubes. So your rule for factoring this, we've got a cubed minus b cubed. So this is the difference of cubes. Again, you're going to get a binomial and a trinomial. The rules for the variables, or the numbers that go in here, are the same. This is a, this is b. This would be a squared. This would be a times b, and this would be b squared. That's identical to the sum of cubes. But then for our signs, we use SOAP, right? This is different, so it's the same, opposite, always positive. That's how I know what my signs are. So on 11, I know I'm going to get a binomial and a trinomial. This is different, so it's same, opposite, always positive. I know this is x. Before you yell out a number, if you already know what the other one is, that's fine, that's great, just shh for a second. We're hoping, and most likely, it would be a perfect cube, right? Otherwise, why would it be in this question? So if you know at least some of them quickly and well, if you can get up to this is 1, 2, 3, 4, 5, 6. What is this most likely? 7, because it's not that much more than that one, right? And then that would keep you from guessing and checking a bunch of different things, but it is 7, so this is x minus 7. So then this would give me x squared. When I multiply these two together, this sign does not matter, because that's just a whole different thing. This is 7x, and this is 49. And I'm done. Okay. What questions do you have? All right, you do number 12. And we should, all along, be looking for a GCF. There hasn't been any, but you always look for that first to simplify your life if it happens. When you're done, you could check yourself with me and then move on to the next section. Okay, I'm going to go ahead and move on. All right, so now we're going to look at factoring trinomials, right? There are different ways to teach this, different ways to do this. I really don't care how you do it as long as you're doing it correctly and legally. So you don't have to change to my ways, but if you are on the fence or it's just really rusty and you kind of need to be retaught, then you probably want to go with my way, because the reason I'm doing it this way is because it should be what everybody could understand and it works with everything else and so forth and so on. All right, so I have a trinomial. A is 1. If A is 1, there's nothing fancy about it. We should all pretty much do it the exact same way. So I need two numbers that are going to multiply to give me a negative 30 and combine to give me a negative 13. Now, before you even worry about that, because it's easy to get all messed up with signs and stuff here, the other thing you should know is that, I know that if it factors, I'm going to get two binomials, right? I know that this has to be m and m. Like, that's kind of a no-brainer. The next thing you can go ahead and do is put your signs in there so that you don't get them messed up, because it doesn't matter which is which. And if this is negative, this C is negative, these signs have to be opposite. So it's a plus and a minus. That means that when I combine the two factors that multiply to give me negative 30, basically they're going to have to subtract to give me negative 13. So if 3 and 10 were the first things that popped into your head, that's not correct, because that's going to give me 7 or negative 7. If this was positive, that would be a different thing. So what are my numbers then? 15 and negative 2. Y'all agree with that?
15 and positive 2.
Negative 15 and positive 2. Okay. Yeah, so the signs have to be opposite, and then since this is negative, it has to be bigger. So just make sure they're in the right spot. You're good. That's it. And you're factored. You're done. Nothing fancy. Okay? When we look at 16, then it's actually a quartic. It's not a quadratic, but it's set up like a quadratic. So that means I can factor it like a quadratic. This is x to the 4th, but this exponent is half of that one, so I can still pretty much do the same thing. I know that I'm going to have two binomials. They're going to have to be x squared and x squared. This is negative, so the signs are opposite, so I get a positive and a negative. And then I need them to multiply to give me a negative 20, and I need them to combine to give me a negative 1. What are my numbers? Negative 5 and 4. Then I got to check it, because I don't have just linear factors here. Can I factor this anymore? This is the sum of squares, and that doesn't exist. There's no rule, right? This is a difference. This is squared, but this is not a perfect square, so I really can't go any farther, and that's it. Okay? But always check. All right, so let's look at number 17. A is not 1, so the first thing I want to check for and would really like to have is a GCF. Do I have one? No, darn. Okay, so here's where you could kind of go differently on how you have done this before. Maybe your teacher taught you divide and slide and you like that one. It's not really mathematically sound, but it works. But grouping is really the way that is probably most of you learned and the way we should go with it. So I'm going to do 2 times a negative 7. That gives me a negative 14. So I need factors that are going to multiply to give me negative 14 and add to give me negative 13. And this is negative, so they need to be opposite. What are my numbers? Negative 14 and positive 1. Right? So then I come over here, and I have to split this middle term into these two things. So this becomes 2d squared minus 14d plus d minus 7. If I'd have put d first and negative 14d second, totally fine, doesn't matter. Okay. Now that I have split it into 4 terms, and all I did was split that middle term, now I'm going to group. I group the first 2 together and the second 2 together, and I factor out GCFs. So out of these first 2 terms, my GCF is 2d. That leaves me with d minus 7. Out of the second 2 terms, there isn't a GCF, but this is a time where even though we don't normally factor out 1, we got to factor out 1. So I'm going to factor out that 1, I get plus 1, and that leaves me with d minus 7. So now I have two big factors. I have this thing and I have this thing. So I can factor out the d minus 7. So d minus 7 comes out in front, and then I'm left with 2d plus 1, and I have it factored. Bam. Okay? You cannot stop at this step. I see that sometimes. Not good. Even when we're solving. We're not solving here because we don't even have an equation, but don't stop here and get your answers. You factor it completely. That is completely factored right there. Oh, they can be switched. Absolutely, yes. And honestly, when I do it, and I'm not just teaching this is how you do it, I would probably write 2d plus 1 first. But the rule, what's really happening is that you're factoring this out, so that's why I'm writing it first. And again, I don't know that I even do the same thing every time, but yeah, they could totally be switched, and you're fine. All right, any questions? Anything else? That was a good question. Okay, so let's look at number 18. Again, it's a quartic, but I can treat it like a quadratic, so I'm going to start off the same way. No GCF. I'm going to multiply 4 times 9, and I'm going to get 36. Okay, so I need it to multiply to give me 36, and I need to add it. I need to add to give me a negative 13. Now, this is positive, which means the signs are the same, and since this is negative, they are both negative. So what two negative numbers can I multiply to get a positive 36 and add to get a negative 13? Negative 9 and negative 4. Okay. So those are my numbers. So that means I take 4q to the 4th, and anytime it's not a square, like just be real careful with your exponents, because if you accidentally drop them off because they look different, then you're really going to confuse yourself in the end. 4q to the 4th minus 9q squared, and then negative 4q squared plus 9. Everybody good with all that? So now I have 4 terms. I've split that middle term. And then I'm going to group these two and these two. And had I put in the negative 4 first, that's fine too. Out of these two terms, the most I can factor out is a q squared. That leaves me with 4q squared minus 9. Then, out of these two, the best I can factor out is a negative 1, and that leaves me with 4q squared minus 9. Then, that'll give me 4q squared minus 9 times q squared minus 1. Can I factor that more? Yes, because those are both what? What's the situation called? Difference of squares, exactly. So then this is going to become 2q plus 3 times 2q minus 3 times q plus 1 times q minus 1. And there you go. Okay. What questions do you have? Okie dokie. So then let's look at factoring by grouping. So in the factoring by grouping, it's basically what we just did, but the middle term's already split. So if you're given 4 terms and you're trying to factor it, then factoring by grouping is what you want to try. Are we ready? I'm trying not to go too fast for you. Okay, so it's already done. We'll just go along the same way as that. All right, I'm going to group those two. I'm going to group those two. So GCF here is going to be h squared. That leaves me with 2h minus 3. Out of these two, I can factor out a 3. That leaves me with 2h minus 3. And if your two binomials that you have in there, they don't match, that's a problem. Then you can't factor it by grouping, or you did something wrong somewhere. So then this is going to give me 2h minus 3 times h squared plus 3. Can I factor that anymore? No. And I'm done. Okay. What questions do you have? All right. I'm going to go ahead and we're going to do 22 together as well, just because I want to make sure I can get through all of what I want to. So I'm going to group these and group these. This gives me z squared times z plus 7. Out of these two, I can factor out a negative 5. That leaves me with z plus 7. Then I have z plus 7 times z squared minus 5. That's not a difference of squares, so that's the best I can do. What questions do you have? Anything at all? All right, so remember, if this is real foggy for you, you're rusty, don't be freaking out. Just get the holes filled in and practice. You have to practice. Okay. Let's move on to the next part here. Okay, so we're going to factor completely, and there's a little remember, always check for a GCF first. So on number 25, do I have a GCF? Yep, 5n. So I'm going to take this equals 5n times n to the 4th minus what? 16. All right. Can I factor it more? Yes, because this is a what? Difference of squares. So then this gives me 5n times n squared plus 4 times n squared minus 4. Can I factor it more? Yes. So this becomes 5n. I can't do anything with the n squared plus 4 because that's the sum of squares and that doesn't exist. And then n squared minus 4 gives me n plus 2 times n minus 2. And I'm done. Okay. Always make sure it's factored all the way. If I lost you somewhere, ask me a question. Okay. So on number 26, do I have a GCF? Yes. So even if there wasn't a 6 in front of that k squared, if there was a negative, I would still say factor the negative out. You always want your leading coefficient to be positive. It'll make your life a lot easier. But my GCF here is a negative 2. So that leaves me with 3k squared plus 7k plus 2. All right, so unfortunately I still have a leading coefficient that's not 1, so I multiply 3 times 2, and that gives me a 6. So I need it to multiply to give me a positive 6 and add to give me a positive 7. What are my numbers? 6 and 1. All right, so now I got to do grouping. So I get negative 2 times 3k squared plus 6k plus k plus 2. Then I'm going to switch my parentheses here to brackets so that I don't get all my little parentheses confused here, because you cannot drop off this negative 2. You can't lose him, do your thing, and go put him back on there. It doesn't work that way. So this negative 2 still has to hang out here. Then I'm going to factor out of these two terms. It's going to give me a 3k, and that's k plus 2. Out of here, I have to factor out a 1, and then I get k plus 2. You could still leave them as parentheses if you want to, but I think brackets are better because then you don't get your parentheses mixed up. And then that gives me negative 2 times k plus 2 times 3k plus 1, and that's the best I can do. Okay. What questions do you have? All right. we're going to skip 28 and 29 because that's just another grouping and that's another sum and difference of cubes. So we're going to do number 30. I was going to give you some time to work on it on your own, but I want to make sure we have time for the quiz. I don't want to be rushing you at the end. So let's do this one together. Do we have a GCF? Yes, and it is 6. So that is lovely because that leaves me with just a 1 right here. I can't factor out any z's though, so this leaves me with z to the 4th minus 5z squared plus 4. Okay. So then this is a quartic, but I can treat it like a quadratic. So this gives me 6, and then I'm going to have 2 binomials. I know they're each going to start with z squared. This is positive, so the signs are the same. This is negative, so they're both negative. So 2 numbers that multiply to give me 4 and combine to give me the negative 5. Negative 4 and negative 1. Can I factor this even more? Yes, I can. Both of these are difference of squares. So this is going to give me 6 times z plus 2 times z minus 2, and then z plus 1, z minus 1, and there it is, all factored. Okay. What questions do you have? Anything at all? Yes, sir. No, I didn't, because my videos, like I'm recording it right now, so I will post it at lunch. So it should be posted before the end of 4th period, hopefully. So you can go back and grab what you missed. Okay. Are we good? Any questions? So once you're done, go ahead and you can submit the notes.